Tomorrow is our midterm. Midterm gonna be based on kinematics and dynamics. Go over test 1, test 2, test 3 and test 4. Test 1, remember the sig fig rules for addition. Take a look. Also go over test number 2 and test number 3, which is based on kinematics. Also go over test number 4, which is dynamics. And I'm gonna make a video on dynamics. Also go over that because you need to understand a few things including inclined planes. So what is that? As you increase the theta, what happened with the acceleration? So this acceleration you're going to find acceleration 1 and this acceleration you're going to find acceleration 2. But our hypothesis is acceleration 2 is bigger than acceleration 2 is bigger than acceleration 1 is because as you increase the theta you get the bigger acceleration. Alright, so what are you going to do? We're going to draw a free body diagram. So let's draw a free body diagram. So this is FG. FG has two components. This is FG perpendicular and this is F normal, and this is what we call FG parallel, as you did in the class many times. And opposite to this one is force of friction. Force of friction is always opposite to the motion, and you need to know that for tomorrow. Okay, so let's calculate it. So we can do it directly. I'm gonna use the two approach, one approach here and one approach here. Whatever you like, you can use. So acceleration is, of course, acceleration is net force over mass. So what is net force? Net force is all the forces acting at the direction in which the object is accelerating. So FG parallel is mg sine theta, and FF is mu k FF. So that's it. So FG parallel minus FF over F. So FG parallel is mg sine theta minus mu k FM over n. Okay. So what is Fn? You remember the Fn is, this one is Fn. Fn is mg cosine theta. Okay, so Fn can be replaced by mg cosine theta. Okay, so what do you get? Acceleration is mg sine theta, so you can factor out m g sine theta minus mu k g cosine theta over m. M cancel. So acceleration is g 9.8 sine 30 degree minus mu k 0.2 9.8 cosine 30 degree. Acceleration is 3.2. So acceleration 1, of course, acceleration 1 is 3.2 meter per second square. Now we're gonna find acceleration 2. This one I'm gonna do it differently. Okay, so let's find the. This is what we call FG. FG has two components, as you saw over there. So let's use the so two component. One is FG perpendicular, which is Fn. The other one is FG parallel, which is also the FF is opposite to that. So FG parallel is of course mg sine theta, and this is mu k, FF is mu k Fn. So perpendicular is mg cosine theta. Since this is opposite in direction, equated magnitude, so this is mu k mg cosine theta. So we can write it again nicely. FG has two components, FG parallel, FG perpendicular. FG perpendicular has another name, Fn. FG parallel does not have a name, but FF is opposite in the direction, but they are not the same. So mg sine theta, mg cosine theta. Okay, and what is FF? FF is mu k Fn. So mu k Fn is how much? Mg cosine theta. Okay, so we have basically done. So we start with F equal to Fn. Alright, so F, what are the F? F are the forces that are acting at the direction in which the box is accelerating. So box is accelerating at this direction, so FG parallel minus what is slowing it down? FG equal to M. So FG parallel is mg sin theta or mg sin theta minus FF is how much? FF is mu k mg cosine theta is equal to ma. Now you can see that we can cancel out m. So acceleration is g sine theta minus mu k g cosine theta. So acceleration is 7.5. So acceleration of this box is 7.5. So this is right. Acceleration of the object 2 is bigger than acceleration of the 1. So as it gets close to, so if it gets bigger as theta approaches to 90 degree, acceleration is approaches to 90 meter per second. This is number 1 etude machine. Let's say this is 200 gram, and let's say this is 50 gram. This is the etude machine number, let's say 1. Now we're going to draw the etude machine number 2. This is 10 kilogram. This is also 10 kilogram. This is etude machine number 2. Now we're going to draw another scenario. This is 10 kilogram. Okay, and there is nothing over here. In all 3 scenarios, here's what I want you to find. I want you to find the acceleration of this one, acceleration of this one, acceleration of this one. Understand that in New York City and many parts of the world, if elevator accelerate more than 2 meters per second, that elevator must be shut down. So to use the elevator must accelerate less than 2 meters per second. So keep that in mind. What else are you going to find? We're going to find the tension force on the rope. Okay, so now let's start our conversation with the first one. Okay, so we're gonna start with we're gonna call this one is mass 1, we're gonna call this one is mass 2. So mass 1 and mass 2. Mass 1, I have the m1g, which is smaller than ft. It's because this guy is accelerating this way. Okay, and this guy is accelerating downward, and you know accelerating downward means negative. Very good. All right, so let's do this one. The free body diagram for this one has to be bigger, so m2g, and ft has to be smaller. Okay, now it's time to put Newton's second law. What do you know about Newton's second law? Newton's second law is, of course, F equal ma at what direction? Y direction. At what type of ma? m1a. Ft minus m1g is equal to m1a. Here F equal ma as well. This is m2a. So Ft minus m2g is equal to negative, because this is acceleration is negative m2a. Ft is, let's make it red, m1g plus m1a replace this by this, m1g plus m1a minus m2g is equal to minus m2a. We're almost there. Anything that has a with it being to the left side, so m1a plus m2a is equal to m2g minus m1g. Factor out the acceleration, m1 plus m2, factor out the g, m2 minus m1. Acceleration is, of course, m1 plus m2 over g, m2 minus m1. Acceleration is g is 9.8, m2. What is m2? Is 200 grams, so 200 gram is 0.2 minus 50 gram is 0.05. all right, and this one is 0.2 plus 0.05. so acceleration is 5.88 meter per second square. I'm going to double check by using calculator. It's always good to double check because just to be safe. That is correct. Is 5.88 meter per second square. This elevator needs to be shut down immediately because if people takes this elevator will accelerate 5.88 meter per second square, and that's not good. Remember our equation. Our equation is, we're going to use that equation. A is g m2 minus m1 and m1 plus m2. You always want m2 is bigger than m1. Okay, m2 must be bigger than m1. Okay, and now what do you see over here? Over here you see that both of the mass are same. So acceleration is g 10 minus 10 over 20. So acceleration is g 9.8 times 0 over 20. So acceleration is 0. Why is that? Because both mass are the same. Now you probably think, oh, how much tension you have, so acceleration is 0. This acceleration is 0. This acceleration is 5.88 meter per second square. Now you probably think, how much is the tension force? So let's find the tension force. So tension force is Ft. So Ft minus, you can use any two, it doesn't matter. This one is m1 m1g minus m1g is equal to ma. A is 0, right? m1a. So Ft is equal to m1g. So Ft is equal to m1 is, of course, 10, g is 9.8. So Ft is 98 Newton. Ft is 98 Newton. All right, now let's check this one. Check out this one. So you have acceleration is, we have the equation over here. G m2 minus m1. All right, so G m2 minus m1 over how much? Over m2 plus m1. Okay, so A is G, m2 is 0, m1 is 10, m2 is 0 plus m1 is 10. G is 9.8. Okay, so G minus 10 over 10. 10 goes to 10 once. So A is negative G. So A is negative 9.8 meter per second square. And that is obvious because this elevator is in free fall, because acceleration is negative 9.8 meter per second squared, as if someone cut the rope by a scissor. All right, so now we can find the tension force on the rope, and you can only imagine tension force has to be 0 here. So this is m2g, so ft minus m2g is equal to m2a. So ft is equal to m2g plus m2a. ft is equal to m2g plus a. All right, so ft is equal to m2, which is 10, g is 9.8, and a is negative 9.8. All right, so ft is 10 times 0, so ft is 0. And that is obvious because there is no tension force on this rope, because this guy is on free fall. Okay, so now we're gonna solve a few other problem. Okay, we're gonna solve a few other problem. Okay, it's fun to solve problem. And now we're gonna look inside the elevator, what's going on. If you stand up on a scale, is gonna measure your, the scale gonna measure your mass, and that's not the weight, that's the normal force, and that's what we are gonna be putting emphasis on. So for scenario, let's consider scenario 1, 100 kilogram. Scenario 2, also 100 kilogram. Scenario 3, also 100 kilogram. Scenario 4, also 100 kilogram. All right, what are we trying to do? This one, let's say the acceleration is negative 9.8 meter per second squared. This one is acceleration is negative 2 meter per second squared. This one acceleration is 2 meter per second squared, and this one constant velocity. Acceleration is 0, but constant velocity. Okay, all right. Now first we're gonna find fg. Okay, so fg is gonna be the same. Okay, let's use the rate for fg. So fg, we're gonna use acceleration due to gravity negative 10 meter per second squared, so that we don't have to use calculator. Okay, so fg is gonna be 1000 Newton. So this is fg. How it is 1000 Newton? 100 kilogram times 10, 1000 Newton. There is another name for fg, and that is the weight. You get fg is 1000 Newton, and fg is also 1000 Newton. Okay, now we're gonna find Fn. This is fg. Now you're gonna find Fn. Remember, elevator reads only the Fn. It does not read the fg. Okay, so we're gonna find Fn over here, and you know the equation for Fn. Fn is equal to mg plus a, or mg minus a. All right, this is accelerating the positive direction, so g plus a. This is accelerating at the negative direction. This is Fn is m g minus a. okay, because this is accelerating down. This is also accelerating down. G minus A. All right, now let's find it. Fn is m is 100, G is 9.8, A is 10, A is 0, acceleration is 0. So Fn is, let's use 10, G is 10, acceleration due to gravity is 10, so 1000 Newton. So Fn and Fg are equal in magnitude and opposite in direction, just because this is constant velocity. Constant velocity, Fn and Fg are the same. Now let's see the other one. Okay, so F is equal to 100, 10 plus 2. So Fn, don't forget n over here, 1200 Newton. What does that mean? That means apparent weight gain. Fn is bigger. Okay, now let's see this one. Fn is, m is 100, G is 10 minus 2, so Fn is 800. All right, so this one is apparent weight loss. Fn is 800 Newton. Finally, we're gonna do this one. Okay, so Fn is, m is I don't know, 100, G is I don't know, 10 minus acceleration. Let's use acceleration due to gravity is 10. All right, let's use acceleration due to gravity is 10. All right, so Fn, A is negative 10. Okay, so Fn is 100, 0. So Fn is 0. There is no Fn. Right, this is free fall. Free fall. So Fn is 0. And now final thing, we're gonna do the apparent weight gain. Apparent weight gain, apparent weight loss, same or weightless. This one is same. This one is apparent weight gain of 200. This one is apparent weight loss. This one is weightless. Finally, heavier or lighter? This one is same. This one is heavier. This one is lighter. And this one is weightless. What are we going to do etude machine? Etude machine is what we call elevator, what you take every day. So etude machine has to do with two masses with the rope. So we're going to draw two mass attached by a rope. Let's draw the pulley. Mass 1, 1000 kilogram. Let's draw the rope. Let's draw the mass 2, 1150 kilogram. Let's make the pulley bigger. That's elevator. We have two masses, 1000 kilogram and 1150 kilogram. What do we need to find? We need to find the acceleration. Okay, so this is pretty simple. A few things. This one is accelerating up. This one is accelerating down. Now we're going to draw free body diagram. We always start free body diagram. So let's do this is, let's call this one mass 1, let's call this one mass 2, mass 1, mass 2, mass 1. How many forces acting on this one? Okay, so M1G, and this is Ft. M1G has to be bigger than Ft because it is accelerating down, so make it obvious. How many forces acting on this one? Alright, two forces, M2G Ft has to be bigger because it is accelerating up. Okay, now we're going to use Newton's second law. So what Newton's second law tells us, F equal to ma. Of course this is negative because this one is accelerating downward. Accelerating downward means negative a. So negative a, this is m1a. So how many forces acting at the y direction? Two forces, Ft minus m1g is equal to negative m1a. What about over here? Over here, let's see. F equal to ma, y direction. Of course, this is positive because this is m2a. This is positive because this is accelerating up. I'm talking this one. So Ft, this is bigger than m2g is equal to m2a. Okay, now if I isolate this one, Ft, what I get? m1g minus m1a. So I can replace this by that. So m1g minus m1a minus m2g is equal to m2a. Alright, so let's see whether we can isolate, we can put all the a together. So let's see. I'm going to send m1a to the other side. So m1g minus m2g is equal to m1a plus m2a. What does that mean? I have common factor g, m1 minus m2. I have common factor a, m1 plus m2. And this is the equation for the elevator. What does that mean? A is equal to g m1 minus m2 over m1 plus m2. Alright, I'm going to write it down over here. Acceleration is g m1 minus m2 over m1 plus m2. So acceleration of g is 9.8, m1 is 1150 minus m2 is 1000. Alright, so 1150 plus 1000. So acceleration is 0.68. We're going to learn two things. One is an object sitting on a table and someone is pulling it by an applied force at some angle, let's say 30 degree or 40 degree or 45 degree, to understand few things like the x component of the applied force, the y component of the applied force, the normal force, the force of friction, net force, acceleration, and the velocity. A box is 10 kilogram on a table, and we're going to pull the box. We're going to pull the box with some applied force. All right, and let's say the angle is 30 degree. Okay, we're gonna find a few things. How many things you're gonna find? 7 or 8 things, and we're gonna put them on the table. First, applied force, and then what else are you gonna find? All right, applied force at the x direction. So applied force at the y direction. This is we call pulling force. So now we're gonna find 7 things, exactly 7 things. F pole at the x direction, and this is F pole at the y direction, and this is F normal, and this is F, and this is F net, and this is acceleration, and finally the velocity. Okay, so you're going to investigate it for 40 Newton, and we're going to investigate it for 30 Newton. Alright, so we have lots of space. We're going to do the math on this space. The first, we're going to find the weight of this box. The weight of this box is mg, and its 10g is 9.8, so 98 Newton. What is the Fn? Be careful, do not write 98 for Fn. Why is that? Because the table receives some help because someone is pulling the box with 40 Newton. 40 newton sum of the force acting at the y direction, and that sum force, probably it is 20 newton, would be subtracted from the weight, and that would be the normal force. So normal force would be less than 98, whatever it is, but it is less than 98. So let's see the normal force. To find the normal force first, we're going to have to do this pulling force, F pull at the, so we're going to first do 40. So 40 at the x direction, 40 cosine 30, which should be 34.6, and 40 sine 30, which should be 20. Okay, so this is 34.6, this is 20. Okay, so 20, so this 98, 20 will be subtracted from 98, and that would be normal force. So what is the normal force? 78. And what is the force of friction? 78, and let's give you a mu k, let's say 0.3. 0.3. So 78 times 0.3, 78 times 0.3 would be 23.4. Alright, so now net force is 34.6 minus 23.4. 34.6 minus 23.4, and that would be 11.2 divided by 10, that would be 1.12, and the velocity would be increasing. Alright, if there is an acceleration, velocity must be increasing. Now we're going to do it for 30 newton. Let's change the color and do it for 30 newton. So F pole, now F pole would be at the x direction and y direction. X direction would be 30 cosine 30, and this is 26, and that would be 30 sine 30, which would be 15, obviously. Okay, good. So this is 26, this is 15. Normal force now is 98 minus 15. Now force of friction would be now 83 times 0.3. So 83 times 0.3 would be 25. Net force would be 26 minus 25, 1. So acceleration is 1 divided by 10, 0.1. Velocity will be still increasing. Applied force acting on it. We'll create a table over here, and let's say a few other things. Mu s is 0.4 and mu k is 0.3. Okay, what else I can give you? I think that's it. All right, so we're gonna finish this table. We're gonna have FA, a different of course applied force. Let's start with 10 newton, and then of course 20, and then 30, and then something else we'll see, and then 40, and then 50. Okay, what else are we gonna find? FF maybe. What else we can find? F normal. What else we can find? FF, F net, and finally acceleration. Okay, this is our goal. So first find the free body diagram. Free body diagram, you see that what are the two forces acting on it? Fg is equal to mg. So m is 10 and g is 9.8, so 98 newton. Normal force is equal in magnitude, opposite in direction, so is going to be 98 newton. The next important thing is we have to find the maximum friction possible. So maximum friction possible is, let's use the different color. Maximum friction possible is F S max, and that would be mu s Fn, and mu s is 0.4, Fn is 98. So 39.2, put 39.2 newton over here. That's very important. Okay, all right, so what is the kinetic friction? So let's use the blue to find the kinetic friction. K is equal to mu k Fn, 0.3 times 29.4. Okay, all right, so let's get it started. All right, the first thing, what are you going to find? FF. So when applied force is, so let's put the thing over here. All right, so this is 10, and when applied force is 10 Newton. When applied force is 10 Newton, think about that. What is the force of friction? Well, the force of friction, minimum force I have to apply to move this box is 39.2. Anything less than 39.2, the box won't move. So is 10 more than 39.2? Well, no. So force of friction would be 10. And the normal force, we already know the normal force. Normal force is 98. Normal force, in fact, 98 for all the problem, all the blank, 98. Okay, good. So force of friction is immediately if you apply 10 Newton, the force of friction. Okay, so what are you going to do? So calculator over here, and you apply 10 Newton over here. The moment you apply 10 Newton, the ground will apply same 10 Newton, all right, equal in magnitude but opposite in direction to keep the calculator at rest. Okay, but the ground can only do so much. In this case, ground can do only 39.2. If you apply more than 39.2 and pull it, and then the ground will give up. So that is when the ground give up. So make sure you understand that part. Okay, so the friction is 10. So when you use 20 instead of 10, you use 20 Newton applied force. 20 is less than 39.2. So then 20. When you apply 30, 30 is still less than 39.2. So 30. 39.2 is not less than 39.2. 39.2 is equal to 39.2. So there would be no acceleration. There would not be any acceleration. Acceleration would be 0, is because the object would move with constant velocity. Object would move with constant velocity. So the velocity would be constant. All right, in this case velocity would be 0, velocity would be 0, velocity would be 0. This case object will move but with constant velocity. Hopefully you understand it. Okay, now net force. What is the net force over here? Of course net force is 0 because object is not moving. Net force is 0. Net force is 0. Okay, good. Constant velocity means net force is 0, of course. Acceleration is 0, acceleration is 0, acceleration is 0, of course. 39 force of friction is still 39.2. Okay, now if you apply force that is more than 39.2, and that is how much? 40. Is 40 bigger than 39.2? Of course, if 40 bigger than 39.2, then what happened? Then kinetic friction takes over, and kinetic friction is how much? 29.4. So you're going to write 29.4. Okay, now we apply 50. Is 50 greater than 39.2? Yes, 50 is greater than 39.2. So the kinetic friction takes over. So then we're going to write 29.4. So now we're going to have to write the net force. So net force, how can we write the net force? Net force is force applied minus this one. So 40 minus 29.4. And that would be 10.6, and this one 50 minus 29.4 is 20.6. all right, so the acceleration is 1.06. so 10.6 divided by 10 is 1.06. this one is 2.06. This one is constant velocity. No, not constant velocity. This one is the velocity increases. Velocity increases over time. This one is velocity increases over time, is because there is an acceleration. Now what are you going to do? You're going to draw a friction graph. The friction graph, that's what you're going to do now. All right, so this is our applied force and this is our force of friction. Y is force of friction, X is applied force. Okay, now let's see. We're going to go by 10, 20, 30 and so on. So 10, 20, 30, 39.2, 40, and then 50. Right? If applied force is 0, then force of friction is 0. If applied force is 10, then force of friction is 10. If applied force is 20, force of friction is 20. If applied force is 30, force of friction is 30. If applied force is 39.2, force of friction is 39.2. 29.4. So what is 29.4? So this is 29.4. All right. Okay. So at 40, this is 29.4. At 50, this is also 29.4. At probably 60, we'll see that this is also 29.4. So what is it? Kinetic friction is constant. What is it? Static friction is less than or equal to 39.2. Why is that? Because mu s Fn is between 0 to 39.2. Anything between 0 to 39.2, and this is the peak, 39.2 Newton.
Brought to you by Brilliant.org.
Bari Science Lab to fall in love with math and science.